All right, so I'd like to bring out Devyn Weiser and Peter Testa. Welcome to the show.
Thank you.
Welcome to the show.
Great to be back on the show.
Yeah, thanks. It's true. We just did a show together not long ago. All right, so I promised that you would teach us how to cook a carbon tower using homemade algorithms. And the reason I thought that, here's some water, by the way. So for the carbon tower, I think it may not be obvious to everyone in the show, but when you go into the gallery dedicated to data, you'll see tendrils of structure coming at you in perspective. And that's how we tried to bring the Weaver script to life. But could you talk a little bit about when the algorithm came into play and when the concept of integrating all these systems into a single construction logic came into play? Which came first, and when the digital came in?
I think the project came before the tools. And that, the thing that's running, Weaver running real time, was a way of actually formalizing, in a strange way, formalizing the system and creating something playful that we could run sequentially without a lot of prejudgment about it, without a lot of work ahead of time, and explore that space of woven systems and woven structures, which was new to us, and we found a way, I think, to start to do that in a way that was quite playful and enjoyable to play
Which
with.
Johan mentioned also, this idea of weaving and fiber and carbon, Johan Bettem, but it seems like that was in the air because of digital technology or because of other things? Just because it was a new material?
Composites was an important part of this project, but that I think that what was interesting for us was the exchange between the digital and the physical, and in a way, thinking about a digital material and getting more friction into the digital world was important. And so it wasn't so much about reworking an older material or your grandfather's material, but looking at materials from another perspective and as being something that was designed as well. So I think that the way of beginning to develop some kind of material behavior within a tool set was part of this project from the early stages of that project, yeah.
But even earlier than that, there had been a whole series of computational experiments that we had done at the Emergent Design Group at MIT, and we had done things with agent-based systems and evolutionary and generative systems, and I think those almost all preceded what wasn't only weaving but braiding at the time, and we had a kind of two scripts in co-development at that time, and both of them I think were interesting to us because rather than taking a kind of surface approach, which most of the projects and even the kind of topological formal projects took, we went into a more vector-based arrangement and really studied how that would link up with what Peter's saying is the kind of computational material. So you had a computational material and a computational geometry kind of working on those two things together, kind of both variables at the same time.
Yep. And what software specifically were you studying these things in?
Initially Alias,
Yeah.
and then like Maya 1.0.
And you were coding these things in Mel scripts or something?
Yeah.
They were written as Mel scripts, yeah.
Some in C++.
Yeah, okay.
So there was some of the work that preceded Weaver were actually plugins to Maya and to Alias actually, and then we started writing scripts in Maya. And those were some of the earliest scripts, I believe, used in architecture, let's say design-based, at a generative phase in terms of other ways of representing a project.
Do you find that approach is, something you still use now? I mean, some software is much more open to that kind of scripting and programming.
Right. I think, I think your point about the complexity and convention is a really interesting notion, and in a way that has become conventional.
Yep.
And now is pretty much mainstream with things like Grasshopper.
Yep.
So we continue to use those kinds of tools, but we don't have to go back and do all of the work that was involved back then. It was, it was a major kind of coding process that we involved other people than ourselves, because it was really serious coding that had to take place to really make these things run.
Yeah, no, because I remember with the embryological house, we were using the same approach with Mel Scripts and Robert Aish and let's say the beginning of the Rhino folks, they were all looking at how we were misusing animation tools and building that into 3D modeling.
Yeah.
And now it's just standard.
Yes.
Now, you were never thinking BIM, but how much of your tower is already fully modeled at the kind of inception?
Well, I think in order to build those physical models that are in the show, it's all geometry, so it's all built.
Yeah,
I mean,
okay.
It's all geometry. So it is, in a way, a comprehensive model.
Yeah.
Well, there's two models. There's the model at the scale of reality, and then there's the model at the scale of the model, right? The model that had to be produced for the STL is a separate model that has, in a way, its own kind of logics and material logics that just have to do with the fabrication.
What could be printed?
What could be printed, how thin, how flat. So that's a kind of a secondary set of representational concerns.
And then it's going to come up when the DARE comes out, but how was computation for those projects at that time? Were you crashing computers right and left?
Yes.
Yeah, okay.
And we were also crashing the 3D printers.
Oh, that's good. And now?
Yes.
Still?
Still.
Really?
Right.
Yeah. Well, that's
Right.
good to know.
Always at the limit. It's a
But
little,
no, you
it's a
feel
little
the
easier.
project would still be crushing.
If you tried to, it depends on how detailed, but there's an awful lot of elements in that project. So yes, you would still be at the limits.
I mean, we talked about it a little bit, I think, in the EPUB, just the representational difficulty of using all geometry or kind of texture mapping for the strands. So, I mean, now we're able to go back and open those files with a lot more ease and move around and be able, but we had all kinds of special file management layers just to be able to operate the model.
And because we're going to have to wrap up, can you talk a little bit about the building systems approach and thinking about it in terms of energy and light and distribution of heating and cooling and all of that stuff you did? Because I think that's not so obvious in the show. It's an interesting thing to hear your words about.
Okay. Well, we worked with Arabs at the middle point of that project, which I guess is something we share in common with with Chemetz. And that one of the factors there was the cooling and also lighting in the building. We had no internal structure, so there was a kind of Miesian space inside the building, and using continuous circulation. So there are these big displacement ventilation, huge funnels, if you will, that run up through the whole building. And that there was also an idea there of using computational tools for airflow to actually adjust. Those tubes were all woven as well, so that they could have variable porosity. So there was, I think, an idea about energy use, a kind of zero energy condition in that project on a lot of different levels.
And I'm getting the zero, but if you could say real quickly, how do you build a 50-story monolithic seamless building?
You build it with robots.
You knew
on
that.
site.
You had to know that was coming.
You build it with robots on site,
Yeah.
and pultrusion robots. And if I could, I would like to make a plug for a book. Is that?
Oh yeah, I haven't been asking people about their plugs. Do you have anything to plug?
Yeah, I have a book to plug that's coming out at the end of this year or in the fall, of which Greg is also writing an essay for a book, Robot House, which is a book on work that we've done for over the past 5 years at SciArc.
Okay, well, that's great. Well, thank you very much.
Greg.
Ulrich, thanks.
This is The Greg Lynn Show with Greg Lynn, produced by the CCA. I'm Devyn Weiser.
I'm Peter Testa. Thanks for watching.